acephysics.org. Math and physics tutoring with Dr. Hudis. If you're interested in math and physics tutoring or in physics-related content, please check out my website, acephysics.org. Hi. Question we're talking about today is if two cylinders with identical mass and dimensions, one being hollow and the other solid, are placed on an inclined plane at the same initial height above the ground and released to roll down an incline without slipping, which cylinder reaches the bottom first? You may want to think about the answer. I'm going to tell you the answer now. Although the explanation of this problem is going to be at the end of the video, I want to tell you a very important point about rotational motion. In a rotating rigid body, particles located at greater distance from the axis of rotation move quicker compared to particles located closer to the axis of rotation. Now, if you notice here, this is a donut-shaped continuous mass object, and if it rotates, A is moving with a quicker speed than B is. Both when A moves all the way around the circle, B also moves all the way around the circle, but A moves a larger circumference in the same amount of time. And so A has a larger linear velocity than B does. Both A and B are locations on this same object, and as that object spins, points on that object have different linear speeds. And that fact leads to many of the kind of interesting and counterintuitive phenomenon that happen within rotating rigid bodies in physics.
Because I'm thinking about the moment of inertia, right?
The moment of inertia is what you should be thinking about.
Yeah, because the hollow one's going to be higher.
The hollow one has a higher moment of inertia.
So is it going to, now I'm thinking, is it going to accelerate? It's going to accelerate slower because it has a higher moment of inertia. Or it might not, but it will be moving with more inertia at the bottom. But I can't figure out which one's going to go faster.
Are you both are students here?
Yes.
You're incoming freshmen?
Yes.
Okay, what are your, this is a microphone, what are your majors going to be?
So I'm planning to do 6-4, which is artificial intelligence and decision making.
Okay, and what about you?
The same thing. I think it's the hollow cylinder because the solid cylinder has its mass distributed in every single part of the cylinder, like evenly.
Hollow one or the solid
It's about
one?
Inertia. It's
About
about this,
moment of
like,
inertia.
yeah, it's about this weird formulas. They have different moment of inertia formulas, but I don't remember in which way.
Mm-hmm.
Like some of them has like 1/2 or something, but again, I don't remember which one.
Well, if I told you, so what do you know about what is moment? Do you know what the moment of inertia is?
Like kind of, I have to understand it, but it's really kind of hard to explain for me.
Well, what's
like,
your best understanding of
best
moment of inertia?
understanding of, it's like, I don't know how to say that. Inertia is kind of like, not the force, but it's really, like, I have some understanding, but it's kind of hard to explain, so.
Solid one wins.
The solid one wins.
Smaller moment of inertia, if that makes sense to people.
That is the right answer.
Yeah.
I've definitely forgotten stuff. I'm going to go with a gut instinct that the hollow cylinder will arrive first.
Okay, it's a solid cylinder.
It's a solid cylinder, okay.
So as this rotates, A moves around and B moves around, but A moves a larger distance than B in the same time, and therefore A has a larger velocity than B does. The hollow cylinder has a larger moment of inertia, making it less responsive to change in rotational motion. As a result, it moves more slowly. Moment of inertia tells how the mass is spread out. If the mass is it's spread out all towards the outside, it has a high moment of inertia. all towards the outside of the rotational axis, where the rotational axis in this case is a line going through the center of the cylinder. So imagine, I guess I have to turn off my camera for a second. So imagine that there's this triangle, and this triangle is rotating. It's a rigid body, and it's rotating at some angular frequency omega. I can break this triangle up into many mass elements. There's mass element 1, mass element 2, mass element 3, mass element 4, and in fact, there's many other ones. I've just drawn 4 of those mass elements. If I want to find the kinetic energy of mass element 1, for example, the kinetic energy is 1/2 mv squared. It's a definition of kinetic energy. V is the linear velocity, and V is equal to omega r, where omega is the angular velocity, and r is the distance from the rotation axis to mass 1 in this case. It's this line right here. And so K equals 1/2 m omega r squared, and I can then pull the omega outside. And so if I want to find the total kinetic energy of this rotating triangle, I'd have to add up the kinetic energy of each one of the mass elements. And that's equal to 1/2 times the sum over mr squared times omega squared, because every mass element has the same omega, it has the same angular velocity, but they have different linear velocities. And therefore I can define this thing, the sum of mr squared, as what we call the moment of inertia. And this tells how the mass spreads out over an object. And so if the moment of inertia is large, then the mass will be spread out towards the outside. And what that means is for a given angular velocity, there's going to be more kinetic energy because the mass is farther away from the rotation axis. And the farther you get from the rotation axis, the larger the linear velocity is, which means the more kinetic energy there is.